Tonight, we're going to explore something that will fundamentally change how you see your place in the cosmos. We're going to discover just how small Earth really is. And I'm not talking about comparing it to the Sun or Jupiter. I'm talking about the true scale, the scale that makes Earth almost disappear. Because here's the thing most people don't realize. Earth isn't just small. It's so incredibly tiny that finding the right words to describe it becomes almost impossible. By the end of this journey, you're going to see our planet and yourself in a completely different light. Before we dive in, if you enjoy these explorations of space and our cosmic perspective, a quick like or subscribe would really help this channel grow. It's a small gesture, but it makes a real difference. Now, let's begin our journey. Let's start with Earth itself, our home, the planet we walk on every day. From our perspective down here on the surface, Earth seems enormous. You could spend your entire life traveling and still not see every corner of it. The continents stretch for thousands of miles. The oceans cover about 71% of the surface. Mount Everest rises nearly 30,000 feet into the sky. To early humans, Earth was everything. It was the entire universe. The sky above was just a dome with lights on it. The ground beneath was flat and went on forever in all directions. This made sense based on what they could see. When you look out at the horizon, the Earth does look flat. The curve is too subtle to notice without getting very high up. Earth has a diameter of about 7,926 miles at the equator. If you wanted to walk around the equator and somehow could walk on water, you'd cover about 25,000 miles. At a steady pace of 3 miles per hour, walking 8 hours a day, that would take you about 3 years and a month. That's a long walk. Earth is genuinely large from a human perspective. The surface area of Earth is about 197 million square miles. To frame this magnitude, if you wanted to visit every square mile and spent just 1 second in each location, it would take you over 6 years of continuous travel. The United States, one of the largest countries, covers only about 3.8 million square miles. That's less than 2% of Earth's total surface. But here's where things start to shift. When you zoom out just a little bit, when you start comparing Earth to other objects in space, it begins to shrink. Not physically, of course, but in significance. Earth stops being everything and becomes just one thing among many. And as we keep zooming out, it gets smaller and smaller until it becomes something almost impossible to see. Our first stop on this journey takes us to our nearest neighbor. The Moon orbits Earth at an average distance of about 238,855 miles. That's roughly the distance you'd travel if you drove around Earth's equator 9.5 times. It seems far, and it is far by human standards. When Apollo astronauts traveled to the Moon, it took them about 3 days to get there. The Moon itself has a diameter of about 2,159 miles. That's roughly 27% of Earth's diameter. So the Moon is smaller than Earth, but not dramatically so. If Earth were a basketball, the Moon would be about the size of a tennis ball. But here's what's interesting. The distance between Earth and the Moon is about 30 times Earth's diameter. Imagine placing 30 Earths in a line between us and the Moon. That's how much empty space exists in that gap. Most people don't realize this. When you see pictures of the Earth and Moon together, they're usually shown much closer than they actually are. The reality is that there's a vast amount of nothing between us and our closest neighbor. This is our first hint that space is mostly empty. Even in our immediate cosmic neighborhood, the distances are enormous compared to the sizes of the objects themselves. The Moon's relationship with Earth is actually quite unique in the solar system. Most moons are tiny compared to their parent planets, but our Moon is relatively large. In fact, the Earth and Moon system is sometimes called a double planet because the Moon is so substantial relative to Earth. The Moon's size has real effects on Earth. It creates the tides we experience every day. The Moon also helps stabilize Earth's axial tilt. Without it, Earth's axis might wobble dramatically over time, causing extreme climate variations that could make complex life difficult or impossible. Looking at the Moon from Earth, it appears about the same size in the sky as the Sunday. This is a complete coincidence. The Sun is about 400 times larger than the Moon, but it's also about 400 times farther away. This coincidence gives us total solar eclipses where the Moon perfectly covers the Sunday. The Moon is also slowly drifting away from Earth. Each year, it moves about 1.5 inches farther away. This happens because of tidal interactions. Billions of years ago, the Moon was much closer, and a day on Earth was much shorter, perhaps only 5 hours long. For now, the Moon remains our closest companion in space. And in 1969, humans walked on its surface for the first time, a moment that showed what we're capable of when we push the boundaries of exploration. Now let's examine the Sunday. The Sun is the reason we exist. Without its light and heat, Earth would be a frozen rock hurtling through space. But the Sun is also where Earth's dimensions truly begin to pale in comparison. The Sun has a diameter of about 864,000 miles. That's 109 times larger than Earth's diameter. The Sun's volume is so immense that approximately 1.3 million Earth-sized worlds could occupy the same space. Consider that for a moment. Every mountain, every ocean, every city, every person who has ever lived, all of human history happened on a planet whose volume represents less than 1/1,000,000th of the Sun's interior. The Sun contains 99.86% of all the mass in our solar system. Everything else, all the planets, moons, asteroids, and comets combined, makes up only 0.14%. The Sun is also about 93 million miles away from Earth. We call this distance 1 astronomical unit, or AU. Light from the Sun takes about 8 minutes and 20 seconds to reach us. If the Sun suddenly disappeared, we wouldn't know for over 8 minutes because the light telling us it's gone would still be traveling toward us. To grasp this distance, consider that a vehicle maintaining highway speeds would require 176 years to traverse this 93 million mile gulf. The fastest spacecraft humans have built, the Parker Solar Probe, takes months to reach the Sun, even though it's traveling at speeds exceeding 400,000 miles per hour at its closest approach. The Sun is actually a pretty ordinary star. Astronomers classify it as a G-type main sequence star, sometimes called a yellow dwarf. It's about 4.6 billion years old, roughly middle-aged. It has enough fuel to keep burning for another 5 billion years or so before it begins to die. The Sun's power is staggering. Every second, it converts about 600 million tons of hydrogen into helium through nuclear fusion. This process releases an enormous amount of energy. The Sun produces more energy in 1 second than all of human civilization has produced in its entire history. The surface of the Sun has a temperature of about 10,000 degrees Fahrenheit. The core, where fusion occurs, reaches about 27 million degrees Fahrenheit. The pressure at the core is about 260 billion times Earth's atmospheric pressure. The Sun also produces solar flares and coronal mass ejections. These are enormous releases of energy and matter from the Sun's atmosphere. When directed at Earth, they can cause beautiful auroras near the poles. But they can also disrupt satellites, power grids, and communications. Looking at the sun reminds us that Earth is not the center of the solar system. For most of human history, people believed Earth was at the center of everything. It took brilliant thinkers like Nicolaus Copernicus and Galileo Galilei to show that the sun was at the center and Earth orbited it. This was humanity's first major lesson in cosmic humility. Our solar system extends far beyond Earth and the Sunday. Let's zoom out and see where Earth fits in this larger structure. The inner solar system is home to the rocky planets. Mercury hugs closest to the Sun, baked and frozen in its extreme orbit. Venus follows, shrouded in its toxic atmosphere. Then Earth, our blue marble, at the perfect distance for liquid water. Mars rounds out the inner worlds, a cold desert that once knew flowing rivers. These 4 terrestrial planets cluster relatively close to our star, all within about 1.5 times Earth's distance from the Sunday. Between Mars and Jupiter lies a vast gap, populated by the asteroid belt. This region contains thousands upon thousands of rocky fragments, the building blocks that never quite became a planet. The largest, Ceres, spans only about 580 miles. More than 13 Ceres could line up side by side across Earth's diameter. Despite containing millions of objects, the asteroid belt is mostly empty space. If you flew through it, you'd likely never see an asteroid with the naked eye. The distances between them dwarf their tiny sizes. Then we reach the realm of giants. Jupiter dominates the outer solar system like a king surveying its domain. With a diameter of about 86,881 miles, it's about 11 times wider than Earth. Jupiter's volume is so immense that 1,321 Earths would barely fill it. This planet is massive beyond easy comprehension. It contains more mass than all the other planets combined. If Jupiter were a hollow sphere, you could fit every other planet in the solar system inside it, with room to spare. And yet, Jupiter itself is tiny compared to the Sunday. About 1,000 Jupiters could fit within the Sun's volume. Saturn follows Jupiter in the outer solar system, nearly as impressive in scale. With a diameter of about 72,367 miles, Saturn could swallow 764 Earth-sized worlds within its bulk. But Saturn's most distinctive feature isn't its size. It's the magnificent ring system that encircles it. Made of countless particles of ice and rock, these rings extend tens of thousands of miles from the planet's surface, yet they're remarkably thin. If you scaled Saturn down to the size of a basketball, the rings would be thinner than a piece of paper. The ice giants, Uranus and Neptune, dwell in the cold darkness beyond Saturn's orbit. Both are smaller than Jupiter and Saturn, but still dwarf Earth. The volume of Uranus equals roughly 63 planets the size of ours, while Neptune's interior could accommodate 57 Earth-mass bodies. These distant worlds take decades or centuries to complete a single orbit around the Sunday. Neptune, the most distant planet, requires 165 Earth years just to make one trip around our star. Beyond the planets lies the Kuiper Belt, stretching from Neptune's orbit outward for billions of miles. This region is filled with icy bodies left over from the solar system's formation. Pluto, once considered our 9th planet, resides here among thousands of similar frozen worlds. Pluto is only about 1,473 miles across. About 5.4 Plutos could line up across Earth's diameter. The Kuiper Belt represents a vast reservoir of primordial ice, a frozen archive of materials from the solar system's birth. But even the Kuiper Belt isn't the true edge of our solar system. Far beyond, almost incomprehensibly distant, lies the Oort cloud. This vast spherical shell of icy objects surrounds our solar system like a cosmic bubble. It begins at about 2,000 times Earth's distance from the Sun and extends outward to nearly 2 light-years. That's almost halfway to the nearest star. Objects in the Oort cloud are so far away that they're barely affected by the Sun's gravity. They're more like prisoners loosely held than objects firmly in orbit. No human eye has ever seen an Oort cloud object directly. We know it exists only because comets occasionally fall inward from this distant realm, their icy surfaces vaporizing as they approach the Sun's warmth. The point is this: our solar system is vast. It extends for trillions of miles, and in all that space, Earth is one small rocky planet orbiting at a distance that's relatively close to the Sunday in a proportional model where the Sun equals a basketball's diameter. Earth would measure no larger than a peppercorn positioned 26 feet distant. You'd need a football field to show the orbit of Neptune at this scale. Let me give you more detail about each of these worlds to really drive home how Earth fits into our planetary neighborhood. Mercury is a small, dense world covered in craters. It has almost no atmosphere, which means there's nothing to protect it from meteorite impacts or to trap heat. Mercury's surface endures temperature swings exceeding 1,000 degrees, from 800 Fahrenheit under direct sunlight to minus 290 in darkness. Earth's atmosphere protects us from such extremes. Our temperature variations are tiny by comparison. Mercury takes 88 Earth days to orbit the Sun, but it rotates very slowly. One day on Mercury, from sunrise to sunrise, lasts 176 Earth days. This means that one Mercury day is actually longer than one Mercury year. Imagine living on a world where a single day lasts longer than a year. Time would have a completely different meaning. Venus is sometimes called Earth's twin because of its similar size, but the similarities end there. Venus has a thick atmosphere made mostly of carbon dioxide with clouds of sulfuric acid. The atmosphere is so thick that the surface pressure is about 90 times higher than Earth's. That's equivalent to the pressure you'd experience if you were 3,000 feet underwater in Earth's oceans. The greenhouse effect on Venus is extreme. Venus maintains a relentless 900 degrees Fahrenheit across its entire surface, trapped by carbon dioxide's greenhouse effect, hot enough to liquefy lead. Venus is actually hotter than Mercury, even though it's farther from the Sunday. This shows what can happen when a greenhouse effect runs out of control. It's a cautionary tale for Earth. Venus also rotates backward compared to most planets. While Earth and most other planets rotate counterclockwise when viewed from above the North Pole, Venus rotates clockwise. No one knows why. It might have been knocked over by a massive impact billions of years ago. Venus also rotates very slowly. One day on Venus lasts 243 Earth days. Combined with its orbit around the Sun, this means the Sun rises in the west on Venus and sets in the east. Mars is smaller than Earth, but in many ways more similar to Earth than Venus is. Mars has polar ice caps made of water ice and frozen carbon dioxide. It has seasons, though they're about twice as long as Earth's because Mars takes about 687 Earth days to orbit the Sunday. Mars once had liquid water on its surface. Ancient riverbeds and lake beds are visible in images from Mars orbiters and rovers. But something happened.